Now the first test, that evaluation test that is carried out for plastic container for parenteral preparation as per IP is leakage test. What do you do in this? You take 10 containers which are under evaluation, the plastic containers which are under evaluation, in which you are going to pack your parenteral preparation. Those 10 containers you are going to take. These 10 containers you are going to fill with water. You are going to fit it with the closure that you are intending to close it with. Okay. And after fitting it with closure, you are going to keep them inverted at room temperature for 24 hours. So you take 10 containers, you fill them, and then after filling them, you close them and you invert them for 24 hours. You should not see any, for the test to pass, you should not see any sign of leakage. If you do not see any sign of leakage, then you can say that the leakage test for this plastic container has passed. The next test that you carry out is collapsibility test. It's quite easy, so I am going a bit fast, but quite easy to understand. The next test that you carry out is the collapsibility test. In collapsibility test, what you do is, whatever containers are intended in which you are going to pack the parenteral preparation, okay, those containers, basically you are going to, this test is applicable for those containers in which the in the parenteral preparation needs to be squeezed and removed. Okay, so for these kind of containers, this test has been applicable. Okay, not for all the containers. So what you are going to do is, you are going to take the containers, you are going to fill the containers, and you are going to press the containers, right? And the contents that are removed from it are at least percent of the contents are removed, okay, at the required rate of flow at ambient temperature. Okay, so from that container, 90% of the contents are getting removed. Okay, when 90% of the contents get removed, then you can say that the collapsibility test is passing. Okay, because you want the contents to be removed from the container. Basically, if you see, yesterday we were talking in the webinar about the eye drops. In eye drops, okay, which are also what you call that, which are also preparation which are sterile in nature. Now for these containers, and they are packed in plastic containers. Now in such cases, what you do is you squeeze them. So what you want is, after squeezing all the contents, okay, if not, then at least 90% and more content should be removed from the container at the required rate of flow, okay, and at the ambient temperatures. You're not going to heat the container, or you're going to not warm the container, right? This is the second test that is carried out after leakage test, that is the collapsibility test. Moving ahead, okay, now in order to carry out further tests, what we have to do is, we have to prepare a solution. This solution is known as, we are going to call this solution as solution S. So how do we prepare the solution S? In order to prepare the solution S, we are going to fill the container which is under test with nominal capacity with water. You are going to close it, and then with the means of the closure by which you are going to close the final container, with that closure you are going to close it. Okay, if not, you can close it with the sheet of pure aluminium, right? And then after, so what you are doing is, you are taking the container, in that container you are adding your water, and you are then closing it, either with the normal closure which you are going to use it at the end, or you are going to close it with the aluminum sheet. And then this container, after closing, you are going to autoclave at the temperature of 121 plus or minus 2 degrees Celsius. At this temperature you are going to autoclave it, right? And this autoclaving you are going to carry out for near about 30 minutes. Okay, you are going to increase the temperature to 121 within 20 to 30 minutes, and you are going to maintain the temperature for next 30 minutes, right? Now what you are going to do further is, if by heating at 121 degrees Celsius the container is getting deteriorated, in that case only you are going to heat it at 100 degrees Celsius for 2 hours. In short, what you are doing is, you are filling the container, you are closing it, and you are autoclaving it at the proper temperature, right, at the required temperature. Once the autoclaving is carried out, okay, this solution S should be used, whatever solution S you have prepared, this solution S should be used within 4 hours for the next test that we are going to carry out. Along this solution S, you are also going to prepare a blank. Okay, how you are going to prepare this blank? This solution S you are going to prepare in your container in which you are going to pack your parenteral products. Whereas the blank is being prepared, okay, thereby pouring this water inside the borosilicate glass. You know borosilicate glass is type 1 glass, isn't it? So this glass is not going to leach out any material, right? Are you understanding? And then this borosilicate glass, you are going to close it with the sheet of pure aluminum, and you are going to heat it at the temperature and time. So this time, that is 30 minutes and 30 minutes, so near about 1 hour. Okay, right? So near about 1 hour you are going to heat the water that is present inside this borosilicate gas, and then you are going to use it as a blank. So this solution you are going to use it as a blank, which you are preparing it in a borosilicate glass, whereas this solution S you are going to prepare it by putting it into your plastic container and autoclaving it, right? The autoclaving conditions have been known to us, and this solution has to be used within 4 hours after preparation. So we have prepared solution S and we have prepared the blank. After preparing solution S and after preparing solution after preparing blank, now these two we are going to carry out for the further test to determine whether our plastic container is of good quality or not, right? So the next test that you carry out is the clarity and color of solution S. The solution S so prepared, as we have seen, should be clear and it should be colorless. The next thing that you are going to check is we are going to check the acid and alkalinity of that solution S, right? How we are going to do is we are going to take near about 4% of the nominal capacity of the container. For example, if the container is of 100 ml, then we are going to take 4 ml. If the solution is of near about say 10 ml, then you are going to take 0.4 ml and so on, right? So we are going to take 4% of the nominal capacity of the container. In that we are going to add 0.1 ml of phenolphthalein solution. The solution should remain colorless, right? It means we can say it is the liquid is neutral, that the solution S is the water that we have prepared, isn't it? Earlier we have taken the container, we have added water inside it, and then we have autoclaved it. So whatever water was present inside it has now converted into solution S. This solution S is neutral in nature. No alkali has been leached out from this container inside this water. Okay, and this is what neutral in nature. Okay, if you add 0.4 ml of sodium hydroxide, okay, then the solution is going to turn pink because the solution has now become alkaline in nature after addition of 0.4 ml, and after addition of 0.8 ml of hydrochloric acid, okay, and using methyl gas as an indicator, okay, the solution is becoming orange red, stating that this solution which was neutral, solution S which was neutral, okay, after hydrochloric acid addition, it has now turned into, after addition of 0.8 ml of hydrochloric acid solution, it has now converted into what? Into an acid. Okay, are you getting me? So initially it is neutral. After addition of sodium hydroxide, it has turned into alkali, and after addition of HCl, okay, it has turned into acid. Okay, are you understanding? So this is how you carry out the acidity and alkalinity test of your solution as that you have prepared earlier. Moving ahead, okay, is about the light absorption, right? You have prepared solution S. This solution S, you are going to do the light absorption using your UV, okay, UV apparatus. You are going to find out the light absorption in the wavelength of 230 to 360 nm. So at this wavelength, you are going to detect the light absorption, okay, and the blank, okay, that you have prepared is going to be used as a blank over here also, right? Are you understanding? So you use the blank that is prepared, and against this blank you are finding out the absorption of your solution, okay, at the wavelength of 230 to 360 nm, and the test passes if the solution S is not having the light absorption of more than 0.20. The light absorption should not be more than 0.20. That is how you find out about the light absorption, right? The next test that you carry out is about the reducing substances. Now, please remember, all these tests are given already in IP. The what you call that? I have already shared those containers का जो reading material that I have already shared with you, and you must have already gone through this. All whatever things have been given. I'm just repeating it for you, right? So after light absorption, what you're going to study is the reducing substances, whether the reducing substances are present in your solution S or not, right? Whether the reducing substances have leached out from your plastic material inside the inside the water, and whether the reducing substances were present inside the plastic container itself. So you are detecting the presence of reducing substances in your plastic container. For this, what you are going to do is you are going to take 20 ml of solution S. In 20 ml of solution S, you are going to add 1 ml of sulfuric acid, dilute sulfuric acid. Okay, and further you are going to add 20 ml of 0.002 molar potassium permanganate. Okay, further you are going to boil it for 3 minutes, and then you are going to cool it, and then you are going to titrate this solution, whatever you have prepared, by adding to solution S. You have added sulfuric acid and potassium permanganate. This solution, you are going to titrate it against your next solution that is prepared by adding 1 gram of potassium iodide, okay, to near about 0.01 molar sodium thiosulfate, and the indicator that you are going to use is starch. Okay, iodometric titration what you carried out. Okay, then after titration you are going to do the same titration. Okay, this you have done with solution S. The same titration you are going to carry out with your blank also, right? And then you are going to find out the quantity of blank that you are going to, the solution S that you are going to use is 20 ml. In the similar manner, blank that you are going to use is 20 ml, right? So you are going to carry out the titration of your sodium thiosulfate against solution S also. Sorry, and you are going to carry out the titration of your sodium thiosulfate against blank also. Okay, and then you are going to find out the difference between the titration volumes. The difference between the titration volumes, okay, of these two, of solution S and blank, should not be more than 1.5 ml. If this is the case, then we can say that the reducing substances that are present are not in high quantity. Okay, let us move ahead with the last test that we are going to carry out, that is the test for transparency. Okay, now in test for transparency, we are finding out whether the plastic container is transparent enough or not. Because why we are checking the transparency? Because we are going to check the particles that are present inside it against black and your light background. Okay, so we are checking the transparency of that container. So in order to check the transparency of your container, what you are going to do is you are going to use the container which you have used previously for preparing the solution S. So that container you are going to take. That container you are going to in that container you are going to fill the standard suspension. That's how to prepare the standard suspension that has been given in your IP. Okay, under 2.4.1. Whenever your IP contains this kind of a thing, okay, in the bracket right there, write down 2.4.1. That is this 2 stands for chapter 2nd. Okay, 4 stands for that sub chapter. Okay, the subtopic 4, and in that point, the first point, that is 2.4.1. Right. So you have to remember in this way, right? So you have to fill that container with standard solution. If the standard container is made up of polyethylene or polypropylene, then you have to carry out the dilution of the standard suspension that you have prepared by this way. I'm not going to go into the details of this. Okay. Then what you're going to do is you're going to do the dilution of 1:200 of the standard solution, and then that you're going to fill in that container, okay, which you have previously used for preparation of solution S. If your container, plastic container, is made up of some other material, then the dilution that you carry out is 1:400. So if it is made up of polyethylene or polypropylene, then the dilution that you carry out is 1:200. If it is made up of the other material, then you carry out the dilution as 1:400 of this standard solution. And after diluting it, you are going to put it into the plastic container. And then you are going to see whether the cloudiness of the suspension can be viewed or not. Okay. And if it is similar as compared to the container filled with water. Okay. So this is how you are going to check the transparency.